Hello friends. So we are learning about ER diagrams and I already have told you about the basic steps to design the ER diagrams, and then we have learned about how we can use those basic steps to design the database model from the ER diagram, right? So let me recall what are those basic steps. So the basic steps for the DB model from ER diagram, okay? So the very first step is the requirement analysis or the requirements. What are those requirements? First we see, right? And that can be given up to by the user, that what are our requirements, what are the what entities we need to have in our database, and what are their properties, how they are related, and so on and so forth. And based on that, we are going to design the ER diagram. Okay, so we have seen a lot of ER diagram about its components, about the constraints, the participation constraints, the cardinality constraints, how it affects the candidate key, the relationship diagrams. Okay, so we have already seen those in the previous video. If you haven't watched, please go ahead and watch those videos. Then we in the third step, after we have designed the ER diagram, we need to design the RDBMS table from the ER diagram. Okay, this we are gonna learn about in this video. And after designing the RDBMS diagram, we are doing the normalization of the database. Okay, so we are going to perform the normalization of the database, right? And after that, we are going to design the physical DB design. Okay, so these are the steps that we need to follow while designing the DB model. Okay, so let's see, we are on the third step, that is designing the minimal DB model or minimum RDBMS table from the ER diagram. Okay, so the topic of the day is designing a given ER diagram into the minimum RDBMS table. Okay, so this is our requirement. So we are converting the ER diagram into minimum RDBMS table. Now what is this minimum? We are going to learn about. So basically the ER model gets converted into the tabular model, that is the RDBMS table. So let's see this with an example. Okay, so here we are going to point to the entity sets as E1 and E2 and relationship set as R. Okay, so let's say E1 and E2 are the entity sets. Okay, and they are related by the relationship set R, and the mapping between the relationship set and the entity set is 1:m mapping. Okay, so this is the cardinality constant that we learnt about. 1:m mapping means one entity of E1 can be related to many entities of E2. That is, if A1 belongs to E1 and B1, B2, B3 belongs to E2, so A1 can be related to B1, A1 can be related to B2, and A1 can be related to B3 as well. Okay, so this is 1:m mapping. We'll see with the diagram. And only single valued attribute. This is very important. And only single valued attribute Okay, so the value would be singled. Okay, single valued attribute and multi-valued attribute. We already have seen that the attribute can be of many values, like example phone number. So one entity can have attribute phone number as 2 or 3 or maybe 4. Okay, so that is multi-valued attribute, but the name would be only one, so it is single valued attribute. So this is the ER diagram model we are given. We can just depict it using this figure also even, and we have two entities, that is, let's say A, and BA is the candidate key of E1, and then we have the relationship R, and the other is E2, and it also has let's say two attribute. C is the candidate key and D is another attribute of E1. And one more thing, this 1 is to M mapping. So here 1 and M, so 1 is denoted by this and M is denoted by this, right? So this is our ER diagram. For R, we have the R as this, and we have A and C, and we already have seen in the cardinality constant that for A and C, what will be the candidate key for R? It will be C. Okay, because for A we don't have the distinct value. We have multiple values repetition, but C will be distinct values. Okay, so C will be the candidate key of R. Now, if we have to make the RDBMS table, we can have this as a separate table, this as a separate table, this as a separate table. So there will be 3 tables whole in all. But let's say we need the minimum RDBMS table. Minimum RDBMS table, that means 2 or more tables needs to be merged. So the minimum could be obviously 1. Okay, so let's say if we can merge all these 3 into one table, is it possible that we can merge all these 3 into one table? We'll see if it is possible, then minimum is 1, otherwise we'll go for 2. Let's say we can merge these 2, possible or not possible. We can see if we can merge these 2 or these 2. So in this way we will see what could be the minimum RDBMS table. That is our requirement. Okay, that is our requirement. So if we have to see this, how we can merge these 2, let's see with this example what I'm trying to say about. Let's say here we have the attribute A. So A can be A1, A2, A3, A4, A5. This is our, we have A and C. C is the candidate key, we already have discussed. And this is, let's say, C. This is for E2, this is for E1. Okay. And C can be C1, C2, C3, C4, C5. Okay. So A1 can be linked to multiple values of C. So A1, A2, C2, A1, C5, and then A2, C2, and let's say A3 is related to C4. Okay. And one more thing is the one-to-one mapping is one entity can be related with multiple entities, but these entities, like if A1 is related to C1. Now let's say if we have to merge these table. So if we merge this like this, okay. So here we will have this A, but A will be related to C1, okay. And we can't have this multiple A value here. Like we can't, in this A is the candidate key. So we can't have this as multiple values, okay. Now if we merge these two, like we merge the relationship R and E2 into single. So we have these values and we have these multiple values. So definitely C will be the key for both of them, right? So let's say here we have C4, okay, and here we have C5. So let's make it unique values only, and let's make it as C3, okay. So if this is the condition of this table, so if we are merging the R into E2, okay, so what will happen? AC will be there and D, of course. C is the candidate key for both of them. Okay, so C will be C1, C2, C3, C4 and C5, right? And here we can have the any values of A1, A1, A2, A3. C is gonna candidate key of both of them and we can have the values of D accordingly, right? So there is no need of any additional work to do. We can easily merge these two. So here R and E2 can be merged together as a single table because both have this candidate key C as the common key. The key is common here, right? But let's say if there is a condition that if we try to merge E1 and R, okay, so what will be the condition here? We have the B and we have the A and we have the C. C is the candidate key of R and A is the candidate key of let's say E1. Okay, so here E1 and R are merged. So A1, A2, A3, A4, A5. Now for A1, for C, we have the values as C1. Also, we have for A2, we have the values as what are the values? For A2, we have C4 and A3, we have C5. A3, we have C5. Now, let's say there will be null values for these two. But if you see some of the entities got missing, like the relationship of A1 with C2 and C3 are missing. Like A1, C2 and A1, C3 are missing from this table. So data should not be missing. And of course, we shouldn't having this null values like this. So definitely if this is the case, we can't merge these two because we have these missing data here. We have this missing relation here. We can't show the relationship of A1 with C2 or A1 with C3 using this diagram. If we try to show here, like if we try to show A1 C2 and A1 C3, then definitely A1A will not be our candidate key, and similarly we can't have the C also as separate candidate key for this diagram. Okay, why? Because we have these two null values. So definitely these two cannot be merged. So this is not a good merge, but this is a good merge. So here you need to decide which two tables needs to be merged so that we can have the minimum RDBMS table. Hence, from this example, we can prove that R and E2 can be merged together as a single table with C as the candidate key for both of them. Okay, so we have two tables now in our RDBMS model, that is E1 and E2R. The candidate key for E1 is A and the candidate key for E2R will be C, right? And it will be represented like E1 A B and the second will be E2R and it will be C D A, and A is gonna be the foreign key for this. Okay, so this is the minimum RDBMS design, right? Let's see another example. Okay, this will be the second example. So E1, E2 are the entity sets related by relationship set R with M is to N mapping, okay, and only single valued attribute. Okay, let's see this, how we can do this. So we have this E1. Let's say it has two attribute, A candidate key and B another attribute. Then we have this relationship set R, and we have another entity set that is E2 with candidate key C and another attribute as D. For the relationship set, we have the candidate key as AC, okay, and this is our R AC as the candidate key. We already have seen that if we have multi-valued attribute, then both together act as a single candidate key for the relationship set R. Now, let's say if we need to combine these two together, okay. So, if we have combined E1 and R together and E2 or R together, both having the same similar condition. So, for E1 and R, we have A1, A2, A3, and let's say it is combined with the C. So for C, we have this A here as the candidate key and AC here as the candidate key, definitely. So these are the values of E1, and let's say these are the values of C1. For AC, we have the combination as A1 combined with C1, A1 combined with C4, A2 combined with C2, and C2 is combined with A3 as well. Okay. And similarly for A4, we have the combination as C5, and C5 is combined with A1 as well. Okay. So this could be the combination. Now let's see if we combine these two together. So what will be the values? So here A, C, E and A1 combined with C1, A2 combined with C2. Then we have this A3 combined with C2 obviously. A4 combined with C5, and A5 is not combined with anyone. Okay, and we have this A1 two times, so A1 is also combined with C5 and A1 is also combined with C4. Sorry, this will be C4. Okay, A1 combined with C4. This is not satisfied. A4 combined with C5, A3 combined with C2, A2 combined with C2. Okay. So A1 combined with C5, if we want to have here, so we need to have a separate, like this A1 should be combined with C5. So A1 won't be the candidate key of this. Okay, and there will be again AC needs to be the candidate key. Here we have the null value because 85 is not combined with anything. We need to show this, right? And this is one entity. If we complete this table, so this will be missing. If we add this, so there will be a duplication of this record again. Okay, otherwise we need to have this here as C5. So this will be multi-valued attribute here. Okay, so in all we can't do this combination. If we are doing this, then definitely our candidate key won't be a here, right? So this way we can't combine this entity set together into one single diagram, right? So that is why, and the same thing will happen if we try to combine this E2 with R also. Okay, the same thing happens because this is many to many mapping, right? So definitely we will lose something, or if we try to add up that in the table, it won't be possible to have the minimum the candidate key as A here, or the in some properties would definitely be lost while we are trying to combine these table. Okay, so that is why we have this minimum table, minimum RDBMS table would be 3 here. Okay, because it won't be 2, it will be even with A as candidate key and E2 with AC as candidate key and E3 with C as candidate key. So 3 tables are required, right? Let's say another example. Here E1, E2 are the entity sets, and relationship set is R with 1:1 mapping, and there is partial participation at both ends and only single valued attribute. Okay, so if we are considering this, then definitely we have this even here, and it is a 1:1 mapping, right? And there is a partial participation that all values are not connected to every other value of both the entity set. So this is like this. Okay, and let's say it has attribute A and attribute B. A is the candidate key for this attribute, C is the candidate key, and B is there another attribute. And for this, we have the relationship set with A and C as the candidate key of relationship set R. Now let's say we need to see how we can combine these into the minimum RDBMS table. Let's say if we try to combine these two, okay, A1, E and R, okay. So let's say for E we have the attribute combination like this. So A1, A2, A3, and for C we have, for E2 we have this combination like this C1, C2, C3, and for R definitely we have partial participation like A1 is combined with C1, A2 is combined with, let's say, C3. Okay. Now if we try to combine these two, okay, so what will happen? We will have this combination as even R, and then we have inside this we have A, C and B. Okay, this will be A, B and C, no issues. Here we have A1, A2, A3, and A1 is combined with C1, A2 is combined with C3, A3 has no combination, and then there will be some values. This value is definitely going to be null here. Okay, and then we have another table as E2 where we have the C as candidate key, C1, C2, C3. If you see here, we have the A as the candidate key, and C has a one value as null. Okay, so we can't say that this is the primary key. This will be the primary key, but this C will also be a key because it has a unique value. Okay, but it won't be the primary key. It will be the alternate key or any candidate key. Okay, primary key are having don't have the null values, but alternate key or candidate key can have the null values, and the C will be the foreign key for this. So this is also the foreign key. So in this way we can merge these two as one table. Now if we try to merge them as together into one table, so this is the minimum table 2 RDBMS table. Let's say we try to merge these two into one single table, if that could be the minimum or not, we are trying to check. So here we have A, here we have B, C and D, and we are trying to merge these two. So definitely A1, A2, A3 and C1, C2, C3 both will come. A1, A2, A3 and C1, C2, C3 will come, but A1 relates to C2, right? So this will be C2, and A2 relates to A1 relates to C1 and A2 relates to C3. A1 relates to C1 and A2 relates to C3, and A3 relates to null. Okay, and we have a C2 relates to null. Okay, let's exceed this, right, and we will include that part that C2 relates to null here, right, and we will be having some values for this. Right, now see here, A1 is a candidate key, C is a candidate key. So both these are candidate keys or alternate keys, you can say, but there won't be any primary key. There is no primary key in this, right? So we have this candidate key as A and C, but there is zero primary key here. No candidate key whose field value is not null. Okay, so this kind of design is not allowed in RDBMS table. There is no candidate key whose field value is null. Right? It seems that there is no primary key here. Hence, this design is not allowed in the RDBMS table design. Not allowed in RDBMS table design. Right? So that is why we can't have the minimum configuration, minimum table as 1. Okay, so for this also our minimum RDBMS table will be equal to 2. Okay, what will be that? Either E1R or E2R. I mean, there could be the two combination possible here. Minimum RDBMS table could be either even R and E2 with the combination as A, B, C. Okay, A being the primary key here and C being the foreign key here. And for E2 it will be CD, C being the primary key here. And this foreign key refers to this. So this could be the combination or vice versa, like E2R and E1. Okay. So this could be the minimum RDBMS design. Why? Because if we combine them together as one, we don't have the primary key there. We have the null values because there is partial participation. This one is important at both ends. If it wouldn't be, then the condition would be something else, right? That also we will see next, that is the total participation case. Before that, I would like to tell you that why in this picture, in the previous diagram, why we were not able to combine them together as one in the multi-valued, in the MS to M mapping. Why we were not able to combine them into two tables is because of this only, right? Because when we try here to combine them, like here you see A, C, B, then definitely we had this C4, C2, C2 repetition again, right? Because A3 is repeated related to C2, there is repetition of this value. And of course, if we introduce C1 here, C1, then it will be null, right? So we can't have this any primary key here also. Okay, there will be no primary key because this value is null and this is also null, right? So there couldn't be any primary key here. Also, it won't be a candidate key also because there is repetition. C2 is repeated 2 times, right? So no candidate key and no primary key in this case. So that's it. We will see some more examples in the next video. Till that, I hope the basic thing how we can convert the ER model into RDBMS table design, minimum RDBMS table design is clear to you. We will be seeing some more illustration of this in the next video, and then we will learn about the self-referential relationship set and the weak entity sets after that. Okay, till that, goodbye, and please keep watching. Okay, thank you very much.